I'm Anil Kumar, and in this video we will learn how to use alternate definition of finding instantaneous rate of change. The question here is, use alternate definition limit when x approaches a for f of x minus f of a divided by x minus a to calculate the instantaneous rate of change of p of t equals to 0.8 t square plus 100 t plus 1000 at t equals to 10. Now in difference quotient we have f of x plus h minus f of x over h, where limit approaches of h approaches 0. Here also it's kind of similar thing. These 2 points in the denominator, they are approaching 0, right? X minus a approaches 0 as x approaches a. So here we can find the rate of change using this formula. So it could be written as limit. Since the function is p of t, we can write limit t approaches when t equals to 10. So t approaches 10 of p of t minus p of 10 divided by, so point A is 10 given to us, right? So t minus 10. So that becomes the difference quotient in this particular case, right? So the difference in the values of p from t to 10 divided by difference in the x values, which is t minus 10, so rise over run kind, right? Where this limit, I should have written limit t approaches 10, right? So that is the rate of change for this. Now we can substitute the values and find the answers. We get 0.8 t square plus 100t plus 1000, that is p of t, right? Minus p of 10 means we'll substitute 10 for t, so we get 0.8 times 10 square plus 100 times 10 plus 1000 divided by t minus 10, limit t approaches 10, right? So that is how we will do. Now here the strategy is to factor. So whenever you're utilizing this form of finding rate of change, then you should concentrate on factoring. That is going to help you to simplify and get the results faster rather than expanding. Okay, so let's combine the terms together. So we have limit t approaches 0. So 0.8 times t square, and this we can take common, so we can write this as 0.8 t square minus 10 square, correct? Then we have plus 100 t minus 10, right? T minus 10 plus 1000 minus 1000, correct? Divided by t minus 10, right? Now 1000 minus 1000 is 0. You are left with these two terms where t minus 10 is common, right? We could write this as, let me add one more step here. We could write this as 0.8 times, this is difference of squares. We could write this as t plus 10 times t minus 10. Now it is very clear. 100 times t minus 10 divided by t minus 10. You get the idea, right? Now we can take t minus 10 common, so we get limit t approaches 10. Okay, so t is approaching 10. We can take t minus 10 common, t minus 10 common, so you're left with 0.8 times t plus 10 plus 100. We have taken t minus 10 common divided by t minus 10. So factoring helps to simplify this particular expression, and now we can take away, cross out the common factors from numerator and denominator. So the expression which we get is limit t approaches 10. So we have 0.8 times t plus 10 plus 100. Now in this expression we can substitute 10 and get the answer. So we get 0.8 times 10 plus 10 plus 100, right? Which is 20 times 0.8, so 8 times 2, which is 16, and well, 16 plus 100, or 116, right? So that is how we can get rate of change of a function using this method. It really helps since we can do factoring and we do not really get involved with expanding and big expressions. So that is a very good and very effective method of finding instantaneous rate of change using this method. I hope it helps. So the strategy here you should remember is to factor and then solve. We'll do a couple of more examples and I hope the concept will be absolutely clear. Thank you.